Let's look at the let's continue to look at the examples, practice quiz, example problems. Okay, suppose I know that in a population IQ is normally distributed with a mean mu of 100 and a standard deviation of 15. I draw a random sample of 100 people from the population distribution and measure their IQs. What's the probability that the sample mean will be greater than 104.5? It's like a variation. Same. It's actually a variation. I mean, it's actually the same thing. It's really similar to the previous example. It's just changing it to this time it's just calling it IQ. So, okay, in the population IQ is normally distributed, and so standard error for this IQ is gonna be standard deviation 15 and draw a random sample 100 people. So standard error for this sample is going to be 15 divided by 10. So it's 1.5. Okay. And what we want to know is a probability that the sample mean of IQ, in distributions of all the IQ sample means is greater than 104.5. Okay, that probability. Okay, so if we get the z-score for that, then we can get the probability that it's going to be higher than this. So z-score for that 101.1 minus 100 divided by 1. Okay, this was the standard error or standard deviation of the sample means. So we're looking at the distributions of sample means, and this is a standard deviation. This is the particular number, the value in the distribution, and this is a mean. So that's how you calculate the z-score, and it's gonna be 3. So standard the z-score for that is 3, which means 0.0013. so it's like less than 0.1% of the population is gonna be greater than 4. Greater than 104.5. Is that right? If it's true, I gotta be one of very few people in the population. The full interpretation: if I take a random sample of size 100 from a population with a mean of 100 and a standard deviation of 15, there is a 0.0013 probability that the sample mean will be greater than 104.5. Right. Okay, let's do some exercises.